How do Pascal's triangle row numbers and entry positions work? Imagine a triangle made of numbers that reveals secrets about patterns and numbers. This is Pascal's triangle, a fascinating tool in math. Each row in the triangle has a special number called the row number, starting from 0 at the very top. The top row is just a single one, and it is called row 0. The next row down is row 1, with 2 ones, and so on. In each row, the numbers are placed in positions that start counting from 0 on the left. So, in the first row, the number 1 is at position 0 and 1 at position 1. The second row has ones at positions 0 and 1, and the third row has numbers in positions 0 through 3. The position tells us where the number is located in that row. The numbers inside each row are not random. They follow a special rule. To find the number at row n and position k, we use a formula called the binomial coefficient. It looks complicated but is simple once you understand it. It is written as a fraction with factorials. N factorial divided by k factorial times n minus k factorial. The factorial of a number is just that number multiplied by all positive numbers below it. For example, 5 factorial is 5 times 4 times 3 times 2 times 1. This formula tells us how many ways we can choose k items from a set of n items. For example, if you have 5 different fruits and want to pick 2, the number of ways to do that is given by this formula. Each entry in Pascal's triangle shows the number of ways to choose items, which connects to the idea of combinations in math. The triangle starts with the 0th row, which has just one number, 1. The next row, row 1, has 2 ones. Every row begins and ends with 1, and the numbers inside are found by adding the two numbers directly above. For example, in row 4, position 2, the number is the sum of row 3, position 1, and row 3, position 2. This pattern makes the triangle grow and develop interesting number sequences. A neat fact is that if you add all the numbers in a row, the total equals to raise to the power of that row number. For example, the sum of row 3 is 8, which is 2 to the power of 3. This shows a strong link between Pascal's triangle and powers of 2. Pascal's triangle is also used in algebra, especially in binomial expansions. The numbers in row n are the coefficients in the expansion of x plus y raised to the power of n. For example, the 7th row, which is 1, 7, 21, 35, 35, 21, 7, 1, gives the coefficients for x plus y to the 7th power. In summary, the row number in Pascal's triangle tells you which set of binomial coefficients you are looking at, starting from 0. The position within that row shows the specific coefficient, also starting from 0. You can find each number by using factorials or by adding the two numbers above it. This pattern connects counting, algebra, and number sequences in a beautiful way.